Hey guys, this is Mr. Chun. We're going to talk about section 2.5 today, which is on graphing transformations. So in your textbook, make sure that you know that this is section 2.5 in your textbook, okay? This is what we did in class. Remember that this is a piecewise dividing function. And if you're having questions about this problem is from section 2.4 in your book, so you can look at that. Okay, we had a quiz. When we talked about the library of functions, you should be able to find the domain and range of all of these, be able to label all of these, find the domain and range in set notation and in interval notation. All right, so this is on graphing techniques. We're going to talk about transformation. We said the objectives of this was to talk about vertical and horizontal shift. Vertical and horizontal shift. Shifts, compression and stretches, and also reflections with respect to the x-axis and the y-axis. Okay, go straight into the examples. We did this in investigation in class, so you should have been able to find what the k, h, a when it's outside and a when it's inside, what those values do to the original function. Same thing with here, the negative signs, what do those do? And here it is, the summary of the graphing techniques. Okay, you can pause this video to look at it. It's also in your textbook. But basically, the k value will affect the vertical shift. The h value will affect the horizontal shift. When there's a constant being multiplied to my f of x, it's going to stretch it vertically, or compress it vertically. And that changes depending on how big a is. Same thing if I multiply my input by a number, it's going to change the horizontal stretch and the horizontal compression. Okay, and of course the negative sign, when it's multiplied to my y value, it's going to change all my y values into negative numbers, so you'd expect it to reflect across the y-axis. Before I put my input in, if I put in a negative x, you would expect it to change my y value, change my location of the x value, so it would reflect it about the y-axis. And we talked about the order of transformations and how, although you can do them in a different order, it's easiest to be consistent, and the recommended order is to do it with reflections first, compressions and stretches second, and then do your shifts. And now let's take a look at some of these examples, okay? So if you want to describe in words how each of these functions are shifted, well, for f of x, we would see the base graph. That's what we have to determine first, right? So f of x would be x squared. So you can see here that the numbers that are different from my base graph are this 3 and this negative 5. We said that if it's positive 3, that's going to be a shift left. Okay, if it's positive, it's going to be a horizontal shift. So you could write shift 3 units left. Okay, and then once you do that, now you have f of x equals x plus 3 squared, right? And now you have a minus 5. So what does that minus 5 do? We're going to have a vertical shift, so we would say shift down 5 units. Okay, whatever my units are for my f of x. Okay, so those are the two transformations that are happening on f of x equals x squared. Okay, what would this one be? G of x. We have an absolute value of x minus 1 plus 3. Well, the base graph is going to be f of x equals x, the absolute value of x, right? So again, this is the same thing. We're going to shift it, and this time, because it's a negative 1, we're shifting it horizontally, right? It's inside my function. We're going to shift it horizontally 1 unit. Okay, so we would shift, in which direction is that? Because it's a minus 1, it would be shift right, okay, 1, and we would shift that 3, because it's positive, it would be shift up 3. Okay, sorry, this should be a g of x. All right. Okay, let's try h of x. Now this one is a little bit tricky. Okay, I need to get it to look like, you can see right away that the base graph is going to be h of x equals root x, right? So what do I need to do to root x to get it to look like this? Okay, the first thing that we want to focus on, remember, is reflections, then stretch and compression, okay? And then we're going to do shifts. So let's start with reflections. Are there any reflections going on? Well, you would see that it's really x minus 1, isn't it? So there are no reflections because all I'm doing is that's still positive and that's still positive, so there's no reflections. Okay? So I'm going to do, it's going to be a shift in which direction? That's a minus 1, so it would be shift right 1, and that's a minus 6, so it would be shift down 6. Okay, so in words, these would be my answers for the corresponding functions. Okay, this is for h of x. Okay. Okay, let's try one more. This time it's graphing the function of f of x equals 3 over x minus 2 plus 1, and then it says I also need to find the domain and range. Okay, so let's think about this. Here I have 3 over x minus 2 plus 1. What does this look like? I have a fraction and I have x in the denominator, so you can think, well, my base graph is going to be f of x equals 1 over x, right? That's really what's happening. So I need to rewrite it so that I can see clearly what transformations are taking place. All right, so let's rewrite this. I'm going to go ahead and factor out a 3. That's really, that 3 right there, that's really 3 times 1, isn't it? Okay, so I'm going to write 3 times 1 over x minus 2 and then plus 1. Okay, so I've noticed that I've factored out that 3. Okay, so now it's ready to be transformed. Now I can see what's happening. Let's describe this. First of all, the 3, okay, you can see there's going to be a vertical stretch. There's going to be a horizontal shift right 2 units and a vertical shift up 1 unit. And the x is positive, so I don't need to do any of the crazy factoring out the negative 1, and there's no reflections here. There's no reflections here or here, right? So the order is reflections first, then compressions and stretches, and then shifts. Okay? So let's do are there any reflections? No. Are there any compressions or stretches? Yes, there are. Which one is it? It's going to be, because of the 3, we're going to multiply or stretch vertically by a factor of 3. Okay? So for every 1 f of x unit, I'm going to stretch it. For every f of x unit, I'm going to multiply that by 3. Okay, from my original. And then I'm going to shift it. Shift right 2 units, and then shift up 1 unit. Okay, 1 unit. All right, so let's go ahead and graph this. What is that going to look like? Here I have x. Here I have f of x or y. Okay, what does the base graph of this look like? We know from our library of functions it's going to look something like this, right? Okay. Well, and of course that's going to be 1, 1. Okay, and that's going to be negative 1, negative 1. Okay, and you should know this. And if you're not sure about it, you can always plug it in. If I put a 1 in here, I'm going to get f of x equals 1. So that's going to be 1, 1, right? Okay. So let's go ahead and erase this. All right. So let's do our first transformation. Are there any reflections? No. So we're going to skip this step. Is there any vertical stretch? Yes, there is. Okay. How is it going to change it? It's going to stretch it vertically by a factor of 3. So that means when x is 1, my output is going to be 3. Okay, my output is going to be 3, 1. So let's redraw that over here just so you can see it. It's going to be 1, 2, 3. It's going to stretch that first point out, and it's going to just stretch the rest of this. Okay, so at negative 1, you're going to expect to see negative 3. Okay, and you would see it do something like that. Okay, so this is now y equals 3 times 1 over x. Okay? All right, let's do our shifts. We're going to shift it right 2 units. So I'm going to go ahead and do this in 1, 2 units and up. So what I like to do is I like to take one of these points as a reference, and I'm going to shift it over 2 points, and then shift it up 1 point. Okay? So that's what it would look like. Oops. Okay, so it would be right here. That would be after shifting it 2 units up or 2 units to the right, and then right there that would be after shifting it up. So a good way to do this when you're doing these types of graphs is actually to look at the asymptotes, because we have two asymptotes. So I'm going to shift my asymptote. This is my original asymptote. I'm going to shift it over to, okay, I've shifted it over to the right 2 units. So that's going to be my new axis, sort of. And I'm going to shift my horizontal asymptote up 1 unit. Okay, do you see that? So this is my new kind of axis here, and then the rest of the graph you can just draw around these axes, so it looks something like this. Okay, same thing with this one. If I want to be a little more accurate, I'm going to go ahead and move this over 2 units and then up 1 unit, and that would be the point that the graph goes through. And so it would look something like this. Whoops, that should go through there. Okay, so that blue graph is now y equals, okay, that should be y equals 3 times 1 over x minus 2 plus 1. Okay, so there's an order. Do these in order, and you should be okay. Start with reflections, do your compressions and stretches, then do your shifts. Okay, so just do it slowly. You'll get the hang of it as you practice these in your homework. Okay. If you did not complete section 2.3 and 2.4, I highly recommend that you do those, because those will be on the test. The assignment for today is section 2.5, page 108, and number 7 to 25, 39 to 63 odd. Okay? If you have any questions, please let me know. Thank you guys for listening.